everyone. In this session, we are going to learn how to find initial basic feasible solution for the given transportation problem using column minima method. In the previous tutorials, you've learned how to find initial basic feasible solution using northwest corner method, least cost method and row minima method. If you have understood row minima method, column minima method is almost the same. It's just that you have to go column wise. In row minima method, you have to go row wise. Row wise is when you have minimum, you have to start with the first row. I'm talking about the row minima method. You have to start with the first row. Consider the cell which has the least cost. Start allocating for that cell. Unless you complete one complete row, you can't go to the second row. If you still have cells remaining in the first row, you have to complete all of them and then move on to the second row. The same way you have to do column minima method. The thing is, you have to start with the column. So we will move on. I will show you how to solve the problem. The same problem I have taken for the previous three methods. The same problem I am taking now for the column minima method also. We will see how to solve it. In the first step, you have to check, hope you remember, first thing you have to do is you have to check whether it is a balanced transportation problem or not. How do you check? Sum of supply should be equal to sum of demand. Here sum of supply is 34, sum of demand is 34. So it is a balanced transportation problem. So to start with, the column minima method says, the algorithm says you have to start with the first column and choose for the cell which has the least cost. So in the first column, 19 is the least cost cell. So we will start allocating for this cell. With supply and demand, we have supply 5 and demand 7. So whichever is least, we will allocate it. So 5. So demand of destination 1 is satisfied. Factory or source S1 has 2 more products with it. We will move on to step 2. If there was 5 here and 7 here, so if you satisfy 5, so this would have gone. If you have had 5 here and 7 here, so you still had 2 more values or rows in the first column. So unless you complete the whole column like this, you can't move on to the second column. So since we have completed the first column, we have to go to the second column. Now we will move on to the next step, step 2. I've just copied whatever we had in the step 1 to step 2 with the updated supply and demand. Here, since we are doing column minima method, we have to consider only the column, the first column in this table. Out of these values of the cost matrix, 8 as the least value. So I'm going to allot for this cell with the supply, with the demand 8 and supply 18, with supply 8 and demand 18. So 8 is less. So I've allocated. We have satisfied the demand of D2. We have left out with 10 more products with S3. Now we will move on to the next step. Now we will move on to step 3. Here we are going to consider the first column again, and we will search for the least cost cell. So 40 has the least cost, so we will allocate it. Out of demand and supply, we have demand less, so we have allocated, and the demand of destination 3 is satisfied with 2 more products remaining with source 2. Now we will move on to the next step with the updated supply and demand. I've just rewritten whatever we had in the previous step. Now D3 is gone. We are left out. D3 is eliminated. Now we are left out with only D4 column. Out of these 3 rows, or in this column, 10 is the least cost cell. We are allocating for this. So 2 is supply is less than demand. So supply from source 1 is completed, but destination 4 requires 12 more products. So if you can see, I have written the sum of supply and sum of demand in each and every step. This has to be written just to cross check whether you have allocated properly or not. After allocation, if you have not copied down the updated supply or demand to the next step, your answer will be wrong. So make sure you write this value, that is sum of supply and sum of demand, in every step, and that should match, that should balance. Initially it had matched, it was 34 supply, 34 demand we had. So each and every cell, after each and every step, after balancing the supply and demand, it has to get updated. So the updated supply and demand should also be equal. So if it is not equal, it is just that you have gone wrong somewhere. Just recheck your steps or answers. Now we will move on to the next step, step 5, where we have S1 got eliminated. We have S3, S2, S3 and D4. So out of 60 and 20, 20 is the least cost cell. Out of 10 and 12, 10 is least. So we have given here, we have left out with 2 demand from destination 4. In the next step, we are left out with only S3 and S2 and D4 with supply 2 and demand 2. So we will allocate it. So supply is satisfied, demand is also satisfied. Now with the next so we had 2 in each and every step. Make sure you are going to write this, though it is very small number. Please don't neglect, keep writing this, make it a habit to write the sum of supply and demand. Now this is the end of all the steps. Now we are done with allocating or supply and demand, balancing supply and demand, satisfying supply and demand. Now next step is you have to calculate initial basic feasible solution from the allocations you have made in all the steps. I've told you in the previous tutorial video also, I keep telling this, you have to write allocation table after completing the supply and demand. After satisfying supply and demand, you have to write allocation table, though it is not a mandatory step in finding initial basic feasible solution. But I want you to write the allotment table so that you will not miss any of the allotments from first step to the last step. So this is the allotment table which we have got from the allocations from first step till the last step. So we have 6 allocations. Now we will find initial basic feasible solution from column minima method. I am writing the method here once again, name of the method. So it is allocation plus cost. Two into 60 plus 8 into 8 plus 10 into 20. So this comes up to 779. We have assumed the cost is given in rupees. So write it as 779 rupees. This is the initial basic feasible solution you have got for the given transportation problem using column minima method.